later. But yeah, when I first met Leo, I thought he'd be a great speaker, and I would love to hear more about Supersight as well. But let's give a big round of applause for Leo. It takes like 5 seconds, so just like.
Gotcha.
All right, speak loud. Yeah.
Okay. Hello. Hi. Hello, everyone. Hi. That's my co-founder there. Thank you all for taking the time to be here today. And a special thanks to Erica for organizing this wonderful summit. She's been very hard at work behind the scenes for a very long time. So firstly, I'd like to request a big round of applause for Erica for this. Great job, Erica. Thank you all for being here today. I'm super excited to be speaking today about intelligent multi-agent coordination networks, and this is a topic that I'm pretty passionate about. So I'm pretty excited to tell you more about what it is, but let me tell you a bit more about who I am. So my name is Leo. Well, actually, it's Advait, but you can call me Leo. And I'm the co-founder and CEO of Supersight. And I previously used to be a researcher in AI, so I specifically published like 57 works in big data, data science, machine learning, and AI. And so what we're building is essentially like the base layer for AI agents. And today we have 175,000 users who actually use Supersight to find actionable insights. And so, I mean, given the background and also my deep love for crypto, which I found through research itself a few years back, so I'm super excited to be speaking to you about the intersection of AI and crypto. And specifically, the research that I was looking at was detecting wash trading in the NFT markets. This is back when NFTs used to be hot and people used to care a lot more about NFTs. I'm sure the hype will come back one day. But so essentially, I was trying to devise graph-based cycle detection patterns to be able to detect the amount of wash trading that was happening. And I also used to be a research partner at Fabric Ventures, lecturer of portfolio management at UCL, and a delegate at MakerDAO. But so that's my background. And today, the subject that I'm speaking to you guys about is multi-agent systems. And but before that, a brief background on the intersection of AI and crypto. So as you guys know, ever since ChatGPT came out, AI has really taken the world by storm. And if you actually look at the number of months it took for ChatGPT to go from 0 to 100 million users, it was actually less than 2 months. And before this, we've been using AI intrinsically in our lives because if you look at recommendation engines, if you look at the different kinds of AI algorithms today, they already play a huge part in your lives. But now, essentially, we're also using it externally by asking it questions on a day-to-day level. And so essentially, AI is eating the world. And so now it's found its way to crypto as well. And if you look at the intersection of crypto and AI, so I mean, the market cap is slightly lower today because it's not great of a month, but that doesn't matter. And so if you look at the landscape itself, so essentially it's projected to reach $50 billion in revenue by 2030. And I don't know if we'll reach there, but it is a pretty bullish statement that Van Eck made, and I tend to believe in it. And so essentially, the intersection of AI and crypto presents a large opportunity. And specifically today, I'm here to speak to you guys about how multi-agent systems actually work and how multi-agent systems have found their way into crypto. And so before we actually speak about multi-agent systems, I think the most important point to note is that they've been around since 1989. So the first mention of multi-agent systems was actually in a conference in 1989, where the conference spoke about decentralized AI. And specifically, the conference was about how multi-agent systems can operate in a decentralized setting. And so if you look at how do multi-agent systems work, before before that, we need to know what is an agent. So an agent is an autonomous program that can be used in any specific setting, which has its own goals that it needs to accomplish. So an agent consists of these different aspects. So firstly, it has some memory, which feeds its context awareness. It also has a world model that is also fed by context awareness. It has a cost, and then it has an actor, which actually decides on which actions to take. So essentially, if you look at the agents here, you can see that firstly, they have some goal that they need to accomplish internally, and then they're actually operating in a shared space with other agents. And so this is a multi-agent system. So essentially, you have one agent do some task, and then it updates the environment. And then the other agent actually develops a perception of this agent, the environment, and this is how a multi-agent system functionally works. And this concept has actually found its way into crypto in a very interesting manner. And so specifically, the way that we actually see multi-agent systems in crypto is, so let's look at the right part of the slide. So essentially, what you can do is, you can do things such as use my wrap Ethereum on ETH to buy the top 5 base NFTs 3 days before the release of Coinbase's next earnings. So here, what you're doing as a user is you're initiating a transaction request, and this is sent to an interface agent. And then once it's sent to an interface agent, then the next step is we actually have to check when are these conditions going to be met. And so there's a coordination agent that is going to monitor when is the release of Coinbase's next earnings, how many days from the next earnings is it, and then essentially once those conditions are met, the agent actually has to pass on the task to the next agent, which is an on-chain data analysis agent. And this agent is going to find the optimal path to be able to execute this transaction. And then once it has decided the optimal path, then you pass that path to a swap agent and a bridge agent who actually perform the task, and then this transaction becomes complete. So multi-agent systems have actually found their way into crypto to enable users to be able to interact with crypto and consume it in a much smoother manner. And so if you look at what's happening here, so in this specific system that I describe here on the right, it's actually a cooperative agentic system where each of these agents are cooperative with a shared goal to fulfill this user's task. And so, I mean, there's many different ways that you can build multi-agent systems. The two main ways are you could either have a cooperative setting or a competitive setting. And so here is a cooperative setting. And then here, in this case, there's no necessity for a hierarchy. It's just a sequential pattern. But there are 9 different types of organizational hierarchies, such as a flat hierarchy, then a hierarchical structure. So basically, the same policies that we use for creating organizations have actually been implemented in various settings to multi-agent systems to put them in an organization together. And so, sorry, there's a 5-second delay. I almost forgot about it. But so in order to actually complete these different actions, agents require context to function. And there's 2 kinds of context that they require. So the first kind of context that they require is intrinsic context. So an agent actually needs to know about his own behavior, his own goals, his past actions. He needs to know exactly why he's doing the task. So he needs to know the intent. And this is all intrinsic context. We've spent a lot of time focused on intrinsic context for agents so far. And the other kind of context that is very important for multi-agent systems is extrinsic context. So essentially any details about the social influence that the agent has, or the organizational structure in which it operates, or changes to the environment where the multi-agent system actually acts. So essentially this is called as extrinsic context. And this is very important to provide to multi-agent systems. systems. So if you look at like extrinsic context, it has 3 types. User-specific context. So here, in our case, like the user's behavior who had like actually requested the multi-agent system. So their consumption behavior, their preferences, all of that. Then the second is agent-specific context. The agent-specific context describes like how does this agent like relate to other agents in the systems. And finally, there is system-specific context, which is like how is the organizational policy organized for the like different agents in a multi-agent system. And so these are the kinds of contexts that are actually required for an agent to like take different actions. And so what we are providing at Supersight is essentially like the extrinsic context that is required for agents to be able to function appropriately. And so like the way that people have been providing extrinsic context to multi-agent systems has been primarily driven by like using retrieval augmented generation to actually pull in like the most similar pieces of information in an unstructured data store and then use them as essentially the context acquisition method. And so what that means is like, I mean, you take the string, you match it in an unstructured data store, you see like which strings have the most similarity, you pick those and use them as a context for actions. But the limitation of this is like RAG only works when like the answers have already been computed before and all you're doing is retrieving it. And if you want to build a multi-agent system in a decision-critical context, then often you also need to compute different insights for the system to function. And so essentially what we are building is a mechanism that combines the use of both structured and unstructured data to be able to support like, and also be able to support computations on the data. And our goal is to equip AI agents with the ability to retrieve or compute the necessary context to perform in decision-critical situations. And I forgot the lag again. But so as you can see, I mean, this is what was happening before Supersight. So the way that we built multi-agent systems so far was that we used like different agents in like a context. We gave each of those agents a role. And essentially, like that's how we were building a multi-agent system. But this is not the most appropriate method to build a multi-agent system to take an action, because here we're not actually factoring the extrinsic context that is required for each agent to operate. And so essentially what we provide is not just the intrinsic context inside the mass, which means like the extrinsic context for each agent and like how the other agents are functioning, but also the extrinsic context with the environment as a whole. So for example, in the example that I provided, we would tell you when your conditions have been met, such as like when Coinbase has its earnings due and how many days from it is it. And then we would also provide like the path for efficient routing to be able to like actually carry out the transaction. And so, I mean, this is something that we are enabling in the case of multi-agent systems. And essentially, like, if you look at like the way that like the general process of a context-aware multi-agent system works, it's actually very simple. So there's only 5 parts to it. Like, first, it's the same as like exactly the same as how humans operate, learn about context, and work in like different settings. So what they do is, first, they actually like sense that some changes have happened in the environment. They learn about them. Then they form some reasoning about them. And then finally, based on that reasoning, they predict, OK, like these are the different actions that I can take. And then they act. And so essentially, like these are the different parts of a context-aware multi-agent system and how it has to function. And so essentially, what we're doing is we're helping a multi-agent systems sense, learn, and reason, and then they have to predict and act. And so essentially, like if you look at this diagram on the right, so here what's described is like 2 multi-agent systems. So imagine you have a DAO, and basically like you have some like criteria within the DAO where you want to pay commissions to certain humans based on whether those criteria have been met. And then You also, let's say that like the DAO makes a lot of revenues in a given month, and based on that, you want to have some expansion plans, which you can program as well. And so essentially, you can also build another multi-agent system that recruits new humans based on the DAO's generated revenue. And so essentially, these two multi-agent systems actually have to coordinate effectively together as well to be able to like ensure like effective functioning of the DAO. And so what we are providing is a context-aware shared world model. So firstly, we'll tell the system on the left when the like criteria have been met, and then the system on the right as well, like the information about a DAO's generated revenues, and then also coordinate these systems to work together. And so essentially, this is something that like we're completely focused on, which is like providing the right context to multi-agent systems to operate. And what this enables is a whole new variety of different use cases. And essentially, like the first kind of use cases that it enables are reinventing DeFi and like reinventing different paradigms in DeFi. So what you could have is like you could have automated LP strategies where you efficiently like manage liquidity across the different markets. You can have new forms of risk management because you can build multi-agent systems that are actually like adjusting their optimal parameters based on the different like events that have happened. And then you can also build like new forms of automated market makers. You can have intent-based matching. And so this is just like what you can do in DeFi, but there are like many different things that you can do outside of DeFi as well. So for example, when it comes to governance, what you could do is you could have like autonomous governance where essentially as soon as a proposal is presented, then there is an agent which actually identifies like whether the proposal has any merit, or let's say that the proposal was just proposed so that the algorithms that monitor proposals like essentially start buying the coin. So you can have like different mechanisms that actually gauge the merit of a proposal before like choosing to display it. And then essentially you can have more agents that what they do is essentially they like study the like voting behavior within a proposal, and then like they optimally like adjust the different parameters that are required for the proposal. And then similarly, like for gaming, like there's a whole new kind of like action that you can do if you know exactly what is going on in the game. So let's say that you want AI NPCs. So essentially, like you could have like dynamically generated NPCs that that take different actions based on your on-chain data of playing the game. And so these are just some examples of what you can do when it comes to like building context-aware multi-agent systems in crypto. And so obviously they have much more uses. So for example, also NFT appraisal, or you could have like vulnerability detection when it comes to programming, content generation, then like AI-driven fleet routing and actually use it in supply chain management systems. And then finally, you can build a completely new kind of social network. But so these are examples of what you can do when it comes to building context-aware multi-agent systems in crypto. And so if you like the talk, then I'd love if you would check out Supersight. And so you can find us here on X. And yeah, feel free to DM us with any questions around like context-aware multi-agent systems or anything of that sort. But thank you all for taking the time to be here today. It was lovely speaking to you.